continue with the lesson on linear motion. And in my last video, I explained the difference, the distinction between distance and displacement. The distance the body covered is the length of path, the path length the body covers during its motion. And displacement is that one has direction, distance covered in a specific direction, the overall change in the position of a body. We continue with this by talking about speed and velocity. Now, the speed is defined as the distance the body traveled per unit time in a given time. It's a scalar quantity because it has only magnitude. Direction does not matter here. It's not usually considered, and the speed is measured in meters per second, and that's the SI unit. It can also be given in kilometer per hour, and you should be able to do the conversion between these two units. Velocity, on the other hand, is a vector quantity because it has magnitude as well as direction. Velocity, in other words, is the rate of change of the position of a body with reference to time. Its SI unit is meters per second. You can also express velocity in kilometer per hour. Now let's come back to look at these two different physical quantities carefully or critically. Say the speed of a body is a scalar quantity, meaning that it has no direction. Let's take, for example, this is your house here at point H. You can decide to maybe ride a bicycle. Let's say you have a bicycle as a student, you ride your bicycle from this house to a point here, let's say to your school, at a speed of 10 meters per second. Or it's possible to also ride at a speed of 10 meters per second to somewhere here, maybe to a mall, a shopping mall. Or you can ride with the same speed of 10 meters per second to your church here at point C. You know, so you now get to see that when we talk about speed, we don't consider direction. You can ride with the speed of 10 meters per second to anywhere, the school, the church, or the mall. But if you must go to the school, you must ride your bicycle in a particular direction. Let's take this direction as my north. This is my east, using my cardinal direction. This is my south, down south, and this is my west. So if I must get to school, or if you must get to school from your house, you must ride in the direction northeast. If you decide to ride northwest, then you find yourself in the church. So it doesn't matter the speed, the direction also matters. So which means from here to the school, that's your velocity. I can say you moved at a velocity of 10 meters per second, velocity of 10 meters per second due that is north of east or east of north rather. So you actually, if you must get to school, you must move at a velocity of 10 meters per second east of north. And if the angle here is 45 degrees, then your velocity is 45 degrees east of north. And you must get to church, you must go in the direction northwest, maybe also the direction 45 degrees west of north. So that's the distinction between speed and velocity. Speed considers just the value, just the amount, just the number measured in a particular unit, whether meter per second or kilometer per hour. But the velocity takes into consideration also the velocity as well as the speed. We can see speed as the rate at which distance is covered. The distance is covered. Let's take, for example, you have to go from, there are 2 points here. Let's take, for instance, there are 2 points, A and B. And then let's say the distance between 2 points is 100 meters. So if you decide to ride or drive at a speed of 10 meters per second, and this is supposed to divide this distance A to B into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that each interval is 10 meters. So if you move at a speed of 10 meters per second, it means that every 1 second, you covered a distance of 10 meters. That's the interpretation of a speed of 10 meters per second. Meaning that after 1 second here, you have covered a distance 10 meters from the starting point A. After 2 seconds, you'll be at a distance of 20 meters for maintaining the same speed of 10. After 3 seconds, you're at a distance of 30 meters from your starting point, and so on and so forth. But if you decide to increase your speed to cover the same distance, probably increase the speed to 20 meters per second, you discover that after 1 second, you have covered a distance of 20 meters. After 2 seconds, you have covered a distance of 40 meters. After 3 seconds, to cover a distance of 6 meters. So as you increase your speed, you cover that distance in a shorter time. So the greater your speed, the shorter the time taken to cover the same distance. So it is the rate at which the speed of a body or the distance is covered. And then the unit of speed, of course, it's meter per second. That's the SI unit. We can also express speed in kilometer per hour. You should be able to convert speed from meter per second to kilometer per hour, so that a speed of for instance 36 kilometer per hour. How do I change that to meter per second? How do I convert that to meter per second? I will do this to convert it to meter per second. 36 kilometer per hour is written like this: 36 kilometer per hour. So that a speed of 36, a distance of 36 kilometers is 36 times 1000. That is 6,000 meters, because 1 kilometer is 1000 meters. 1 kilometer is 1000 meters. So it gives you that over 1 hour. Change that to seconds, because that 1 hour is 60 minutes, and then 60 minutes is, or 1 minute rather, is 60 seconds. So 1 hour is 60 times 60 seconds. So by the time you evaluate this, you are going to get 10 meters per second as your speed in meters per second. So you'll be able to convert speed from kilometer per hour to meter per second. So now, quickly before we round off this session, we want to look at the different types of speed and velocity. Types of speed and slash velocity. I'm going to look at them together. Speed has different types, and of course, you know that speed has been defined as the rate of at which a distance is covered, or distance covered per unit time. So firstly, we have what we call instantaneous speed. Instantaneous speed or velocity. Now we define this speed as the speed of a body at a particular instant, at a given time. This speed can be viewed or can be seen on the speedometer of any vehicle in motion. Have a vehicle in motion. By the time you take a look at the display on the speedometer, the speed that is registered on that speedometer, that speed is called instantaneous, because it's subject to change. It can be given as change in displacement over change in time at a particular time t. That we call that instantaneous speed. Then we also have what we call rotational speed. Rotational speed has to do with the speed of a rotating body. For instance, the blades of a fan rotates when the fan is turned on, or the wheel of a car that rotates when the car is being driven. So the speed of rotation, rotational speed, the symbol is omega. It is given by the linear speed or tangential speed over the radius of the circle, or radius of the body. Okay, so that is given, that's rotational speed, the speed of a body that is rotating. Then we have to have tangential speed. Tangential speed, that is the speed of a body, the linear speed of a body that is moving in a circular track. The linear speed of a body moving on a circular track is called the tangential speed. It is given by V equals rotational speed times radius of the circular track. Then we have the relative speed. It's the speed of a body as compared to another. It is the speed of a body as seen or reference to another body. Just like you have two bodies moving this way, let's say in the same direction, but this body A is moving at a speed of 50 meters per second, for instance, and body B is moving at a speed of 30 meters per second. Now we can talk about the speed of A relative to that of B. By comparing the two speeds, we bring out their relative speed or velocity. So these are the different examples of speed. Then lastly, we look at uniform. Another word for uniform is constant speed or velocity. Now, when you say the speed of a body is constant, it means the speed of the body does not change. It is not subject to change with time. That is, this speed does not depend on time. We call that uniform or constant speed. I need to note that when a body moves at a constant speed, its acceleration is zero. A body moving with unchanging speed is said to have a constant a zero acceleration. That is, the body does not accelerate. Now, in the case of velocity, for the velocity of a body to be constant, it means number one, the magnitude of the velocity must be constant. Two, the direction must be constant, because velocity is a vector quantity. The speed there, or the magnitude of the velocity, represents the speed. So when a body is moving at a speed of 10 meters per second in a straight line, That is, the direction is not changing. Here we say its velocity is constant. That is, when its body is moving at a speed of 10 meters per second along a straight line, then we say that the velocity is constant. So, but if this body moves at a speed of 10 meters per second, and then that's in terms of magnitude, this is constant. But the direction is changing. It keeps changing direction. Probably it's moving around the circle or moving, changing direction as it moves. In this case, we say this body's velocity is not constant, though the magnitude, which is the speed, is constant. But as long as the direction is not constant, the velocity is not constant. So for you to have constant velocity, number one, the direction must not change. Two, the magnitude, the value, the amount of the speed must not change. So if it moves with a speed of 10 meters per second along a straight line, we say the velocity is constant. It's constant. So we have this as the for uniform speed and velocity. Then the last one is non-uniform speed or velocity. The body speed in this case is changing. For non-uniform speed, the speed changes with time. Since the speed changes with time, we say in this case the body is accelerating. So when the speed of a body is not uniform, or the velocity of a body is not uniform, meaning that it's not constant, it means the body is accelerating, or let's say decelerating, which is negative acceleration. So the next video we shall look at acceleration. Okay. So lastly, you can also go through. I'm going to post on this same video the difference between speed and velocity and their similarities. We have another speed we call the terminal velocity or speed. Terminal velocity occurs when a body that is moving through a particular fluid, moving through air or liquid, is being opposed by the system, by the medium, by the air or by the liquid, such that with time the body attains a constant velocity. A constant velocity. In that case, that constant velocity is called the terminal velocity of the body. Thank you.